In this video, I'll be discussing about how to determine functional dependencies by using the given relation. For example, here I have a table with 4 attributes A, B, C, D, and these are the tuple values. And by using this table, we have to determine functional dependencies like A tends to B, B tends to C, C tends to D, or D tends to B, something like that. So to do that, we have to remember this statement, that is, two different values of B are not related to same A. For example, if I consider the functional dependency A determines B, then two different values of B are not related to same A. That means, for example, according to this data, left side for A value A1, A1, if I have like this, I should not have two different values for B. So you can check this example with the statement, two different values of B are not related to same A. But here these are related to same A, so we will not consider A tends to B as functional dependencies. So here I have written some of the examples, or just we are checking whether A tends to B holds good or A tends to C holds good, something like that. So let us check the first combination now, A tends to B. So what is the statement we have? Two different values of B are not related to same A. So here we are checking for A tends to B. So according to the statements, two different values of B are not related to same A, but here it is related to same A, so this functional dependency we cannot consider. Next we will check for A tends to C, A tends to B is done. Next check for A tends to C. So what is the statement we have? Two different values of B. That means here, since we are considering A tends to B, I will consider this value as C. So two different values of C are not related to same A, but here it is related to same A, so we cannot consider this as functional dependency for this table. It is something like, by using same USN, we are determining two different student name, something like that, but it is not correct according to the characteristics of database or a primary key, so we will not consider this as functional dependency. So functional dependency is nothing but prime attribute can determine non-prime attribute. So next one we will consider B tends to C. So B tends to C. So two different values of C are not related to same B. For example, here you can check two different values of C are not related to same B. It is true because we have two different values in B and also two different values in C. So we can consider this as functional dependency. So that means by using B values we can determine C value. And also here you can check two different values of C are not related to same B. That is also true. Then we will check here with a combination of C1 and C4. So two different values of C are not related to same B. Are not related to same B. That is also true. But here you can check C2, C2. So two different values. It is not two different values, but here we have same value C2, C2, which can be determined by B2, B2. That means, for example, USN B2 can determine, for example, Ram. USN B2 can determine Ram. Same USN, same name we have. So this is a valid functional dependency. Then we have D determines C. So D determines C. So two different values of D are not related to same A. It is true. This combination is true. We will check for this one. Two different values of D. Sorry, we have to check here. So two different values of C are related to same value of D. So this is not a functional dependency. Next, C tends to B, D. Two different values of D are related to same C. So this is also not functional dependency, good functional dependency. Then we have B tends to A. We have checked for A tends to B, which is not a functional dependency. Then we will check for ulta, that is B tends to A. So two different values of A are determined by same value of B. So this is also not a good functional dependency. Next we have C tends to A. So two different values of A are determined by same values of C. So this is also not a good functional dependency. Next we have C tends to B. C tends to B. We have checked for B tends to C. It is a functional dependency. Now we will check for ulta, that is C tends to B. So for two different values of B, we have two different values of C. So this is also a functional dependency. We can consider that as a functional dependency. Next we have another kind of key, that is composite key. A comma B tends to C. So here also two different values of C are determined by two different values of AB, because the combination of these two is different and these two is different. And also here you can check. So the two different values of C is determined by two different values of AB. Again, the combination of this is different, the combination of this is different. So just like that, you can check for A tends to B, A tends to C, A tends to D, B tends to C, B tends to D, B tends to A. All the combinations you can check, and also you can check for the composite keys like this. And you can determine these types of functional dependency only when the values are given in the table. If you do not have values in the table, just they have given the schema, just like ABCD, or just like USN, student name, address, all those things, then you cannot determine like this by using this statement. Just you have to use your common sense, then you have to write on your own assumptions.